Welcome to text pre-processing video. My name is Eun-Seok Chang and I'm a doctoral student at Carolina Health Informatics program. And my research interest is text analysis of electronic health records. In this video, I will talk about text pre-processing, which is an essential step of text mining. Before we move on, let me first introduce what text mining is and its real-world applications. Text mining is the process of deriving information from text. You can figure out the patterns and trends in text using statistical learning and predict future trends in text. By taking advantage of text mining, we can determine whether a hotel review on TripAdvisor is positive or negative, predict whether a news article is talking about politics or economy, correct spelling errors made by search engine users, and with text mining tools at my hand, there should be more high-risk patients than I was able to find by simply querying diagnosis and procedure codes. In text mining, individual words like the article A, dog, tree, or rock are the unit of analysis, whereas numerical values, which we often call variables, are the unit of analysis in data mining. To pre-process your text simply means to bring your text into a form that is predictable and analyzable for your task. This is needed for transferring text from human language to machine-readable format for further processing. In other words, it transforms text into a more digestible form so that machine learning algorithms can perform better. So how do we go about doing text pre-processing? Generally, there are three main components of text pre-processing: tokenization, normalization, and noise removal. Tokenization is about splitting strings of text into smaller pieces, which are called tokens. Normalization aims to put all text on a level playing ground, like converting all characters to lowercase. Noise removal cleans up the text, like removing extra white spaces. The Jupyter Notebook will give you a guidance and template for text pre-processing. In this video, I will talk about the basic concepts of text pre-processing. In this lecture, I will talk about tokenization. I will also cover the topics of removing special characters, stopwords removal, stemming, and lemmatization, which belong to the normalization process. Tokenization is the process of splitting the given text into smaller pieces called tokens. Larger chunks of text can be tokenized into sentences, and sentences can be tokenized into words. In this lecture, we will limit the idea of tokenization to breaking a sentence into individual words, numbers, and punctuations. In this case, punctuations are also recognized as tokens. Further processing is generally performed after a piece of text has been appropriately tokenized. Then, how can you tokenize this sentence? There are various strategies for identifying token boundaries. Let's take a closer look at this sentence. Clearly, the period at the end of the sentence should be an individual token. But are the periods in the doctor or colonel also tokens? How about apostrophes? Is the apostrophe in the word Smith an independent token? Well, we can choose between competing strategies, such as keeping the punctuation with one part of the word or discarding it altogether. One of these approaches just seems correct and does not seem to pose a real problem. It is possible to remove stopwords using Natural Language Toolkit or NLTK of Python, a suite of libraries and programs for symbolic and statistical natural language processing. When we tokenize this sentence using Python's NLTK package, this sentence will be tokenized like this. Notice that the NLTK tokenizer did not separate dots from nouns when they were abbreviations, while the period at the end of sentence is an independent token. Also, the apostrophe is an independent token, so the possessive s is an independent token. Let's move on to the next topic, removing special characters. Removing special characters is one of the normalization processes of text data. Special characters like caret signs, asterisks, pound signs, exclamation marks, and question marks do not provide us much information. Those characters only increase the number of features we have to deal with. Not only do special characters add to the extra noise, they also slow down the computational speed. So it would be a good idea to remove special characters before we go on to the next steps of text analysis. For example, we can remove special characters from this sentence to look like this. Notice that the exclamation mark, pound sign, and @ sign are removed, while letters and numbers are survived. Let's talk about stopwords. Usually, stopwords are the most common words in a language. Typically, these can be articles, conjunctions, and prepositions like a, on, is, all, and so on. These words do not carry important meaning and are usually removed from text. We want to remove them because we would not want these words taking up space in our database or taking up valuable processing time. In this example, the, and, if, are, is, and not are stopwords. After tokenization and stopwords removal, this sentence will transform into this. But oftentimes, negative expressions like no or not provide us very important information, especially when we conduct a sentiment analysis. Let's do an exercise. Consider the following reviews that are already annotated for you. The first 3 reviews are positive and the last 2 reviews are negative. But after we remove stopwords, do their class annotations look unchanged? Remove stopwords using the code provided in the Jupyter Notebook and see how each review looks like after stopwords are removed. Critically argue whether stopwords removal can improve the performance of sentiment analysis in any context. Go to the Jupyter Notebook and do exercise.